Now that we've learned about individual fatty acids, what we want to do is start thinking about how these fatty acids combine together to produce the two main forms of fats in our body. And these are phospholipids. All right, these are the compounds that make up the lipid bilayer, and also triglycerides, or you might hear them called triacylglycerides. So this video is going to focus in on triglycerides because they're a little bit simpler. Okay, so with triglycerides, we end up having three fatty acids that combine together into one molecule. Okay, and they do so by linking together with a compound called glycerol. Glycerol is a 3-carbon compound where each carbon has a hydroxide or an alcohol group hanging off of it. Okay, so we have CH2 here, CH, and CH2. So this compound is glycerol. And what we can see here is that we have 3 alcohol functional groups that can all be modified. Okay, so we have our 3 alcohol groups on glycerol, and to those 3 alcohol groups we're going to attach our 3 fatty acids through a condensation reaction. So let's show what this ends up looking like, and then we'll show the 3 steps in a little bit more detail. Okay, so what we end up with is our glycerol backbone. And we still have the 3 oxygens from the alcohol, but each of these have been condensed with a fatty acid to form an ester. And I'm going to go ahead and abbreviate our fatty acid chain, or our carbon chain, as R, and R prime, and R double prime. So we end up forming 3 esters, and the only difference between our esters is what the fatty acid chain is. Okay, so this is what our triglycerides end up looking like. This is the form of fatty acids in our fat tissue, or our adipose cells. And again, these molecules form through 3 sequential condensation reactions between glycerol and a fatty acid. So let's take a moment to think about one of these condensation reactions in a lot of detail, and then we'll think about the other 2 a little bit more quickly. Okay, so let's start off with glycerol. So we have our glycerol. Here's our 3 carbons with an OH. We have another OH here, and we have our 3rd OH. Okay, so for this very first step, this part of the compound isn't really important. We're going to focus in just on this alcohol. Okay, and we know that this alcohol group is going to condense with a carboxylic acid functional group from a fatty acid. Alright, so let's go ahead and put in our lone pairs. So this reaction is going to look absolutely identical to the condensation reactions we've seen in the past. So the very first step is our nucleophile, these lone pairs which are nucleophile, attacking this carbon, right? So forming a covalent bond, and these electrons get pushed up onto our carbonyl oxygen. The product of this first step is going to look really similar to things we've seen in the past. So we still have the main functionality of our glycerol. We have the OH here, but this oxygen is now linked up with the carboxylic acid of our fatty acid. Okay? You may remember that in the next step, what we need to do is switch the position of this positive charge. So we have the lone pair on this oxygen reaching out, grabbing this proton, and pushing the electrons over to the oxygen. So again, we're left with the main chain of our glycerol, This oxygen now has 2 lone pairs. We're still linked up with our carboxylic acid, but now this oxygen has the positive charge. So then the final step is reforming our double bond and breaking away water. So we end up with water and a new ester, right? So here's the ester that we expected to form. Okay, so this is the mechanism for a condensation reaction that we've seen before. The only difference is there are some kind of big stuff hanging off the two ends. So really, don't worry too much about that other stuff hanging off. What's important here is that you have an alcohol and a carboxylic acid condensing to form water and an ester. So if you can draw a mechanism for that process, then you can draw a mechanism for this process. Just take your time and think about what's attached to each atom. So what you'll note here is that once we have this first condensation reaction done, we still have 2 more alcohol functional groups that can condense with another carboxylic acid from a different fatty acid. And if we undergo 3 of these condensation reactions, then we end up with our triglyceride, which is our glycerol backbone. You can see the glycerol backbone here, attached to 3 different fatty acids. So fatty acid number 1, fatty acid number 2, and fatty acid number 3. So if, for example, you were asked to draw a triglyceride made of 3 16-0 fatty acids, then you should be able to do that. So you draw your glycerol backbone. We know that we have 3 alcohols hanging out, and our fatty acids are 16-0. So they're all saturated. So we have our first carbon, right? This is the ester linkage. And now we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 carbons. So this is the first fatty acid condensed with our glycerol. The second one looks the same. "16 carbons. The third one also looks the same. 16 carbon fatty acids. In the next video, we will explore phospholipids, which are the building blocks for lipid bilayers.